Hi Engineering Janta, I am Vaibhav Shukla and today we are going to understand about queues. This is another video in the free DSA series that we are building so that you thrive high in your career. Before the queues, I have covered the stacks, I have shown you its basics, its operations, their implementations. We have solved few problems in this playlist. So what you can do is, if you haven't watched this playlist yet, go ahead, cover the previous topics first. Also, I have done lead code easy as well as medium level problems. Fine. We will pick up more medium level and hard level problems once we are done with queues and linked list. Then we'll go ahead and do a lot of problems. Right now, I'm laying your foundation. Alongside that, I am making you practice easy to medium level questions. I have also covered medium level and certain medium to hard level questions like min stack for the stacks, and similarly I'll be doing in queue and linked list. So for those who are thinking that are there any more problems for stacks? Yes, there are, but after queues and linked list, then we'll dive in deeper in the hard problems. Find the lead code hard problems which are rarely asked, but whenever they are asked, they're really good companies who ask them. Fine, so you need to be ready with them as well. We'll dive in deep in that, don't worry. But right now, focus on maintaining your basics. Prepare the bedrock on which a beautiful building can be made. Fine, I'll dive in deep into this and let's understand what is a queue. So, as the name suggests, this is the queue. Fine, easy peasy, nothing difficult. Aasan kaam hai. Dekho. Consider that a few people are standing in the line of ATM or the queue of ATM. Fine. So what does it suggest? The person who is right now operating the ATM must have come first than all of these, isn't it? He must have come first than all of these. And subsequently, all the people who are standing in this order, this lady came before all these people, this person came before these two individuals, and this person, the red t-shirt person, might have come in last, isn't it? So this is a queue. Similarly, in the queue data structure, you have certain elements. Fine, say this is a queue. You will have certain elements, say 14, 15, 16, 17. You might think that this is an array. You might think that. However, it is not. It is not. Why am I saying so? There are certain key differences in a queue that you will understand right now, and then you'll get an absolute clarity that why queue is different. Fine. So when I come to a queue, let's understand the Enqueue and Dequeue operation, because this will give you the better clarity about queue. Fine. And later on, we will understand what are the principles that it operates upon. So consider that this is a queue. Fine. And these are all empty spaces, fine. So you have two values, or you can say two pointers, front and rear, fine. So both are initialized as -1. Why they are initialized as -1? I'll tell you later on. For a while, just consider both are initialized as -1, fine. Now, when I want to add a new value to this particular queue, I will add a new value. Fine. This is right now absolutely empty queue, so I'll add one value here. Once I do that, once I put the value here, then we will see how these front and rear work. Fine. So right now they're at -1. Consider that 10 is the value that I'm putting inside the queue. So this putting inside the queue is called Enqueue. Fine. Using Enqueue operation. For example, in stacks, you were using push operation. You can consider Enqueue as the corresponding of push. Fine. This is corresponding operation of push. Just like push does operate for stack, similarly Enqueue operates for queue. Fine. So this operation lets this 10 enter the queue. So I will first of all, whenever you are entering any particular point or any particular value in queue, what you should do is increment the rear, fine, and then add. Always remember, anything that is enqueued in a queue is added from rear. किसी भी क्यू को इमेजिन करो, कंसिडर अ लाइन. फॉर एग्जाम्पल, I'll come back to this example only. If now a new person wants to come, can he enter anywhere between these? No, he cannot. A new person, say this is a new person, has to come here, isn't it? A new person has to stand behind this. So new addition can be done from the rear end only. Fine. New addition can be done from the rear end only. Now I go ahead and I update rear. So rear becomes 0, and consider this is 0. So at this point I add 10. Fine. So now here you can consider that rear is here now and front is somewhere here at -1. Fine. But what you should do is you should also update front now, because there is only one element. We'll further understand how Enqueue and Dequeue are implemented. Right now, do not consider that I am doing this according to the code that will be implemented. Do not consider. Just imagine that there are 2 pointers and we are trying to add or trying to remove the few values from the queue. Fine. So again, I'll increment front as well so that I get front here. Fine. Now in this case, now the front is generally here until unless any Dequeue is done. Whenever Enqueue is to be done, rear would be changed. Whenever Dequeue would be done, Dequeue is an operation where you remove an element. Fine. In that case, front would be changed. Fine. But right now there was just a single element, so I have incremented the front so that we have front and rear. For the first element, it generally happens like that. Now we go ahead, and for Dequeue, consider that first of all we add one more element, 11. So first of all, what should be done? I should go ahead, increment the value of rear, or basically I should add from the rear portion. I should come from here, see the vacant place, and add the 11. Now I say 13 should be added. I come from here, check this is the empty place, rear, I increment and rear starts pointing here, and then 13 comes here. As simple as that. Fine. So this is the basic how Enqueue happens. Now when I talk about Dequeue, remember one thing, Enqueue was being done from behind. It was being done from the rear portion of queue. Fine. So whenever you try and add a new element to the queue, you add it from the last. But if you want to remove anything, if Dequeue has to happen, then Dequeue will happen from front. Fine. Dequeue will happen from front. It cannot be possible that I say that Dequeue and 13 is removed. It will not happen like that on principle of queue. Fine. On that, first of all, 10 should be dequeued or removed. So Dequeue should happen from front. So this would be, say I Dequeue 10. Just imagine I am writing it here. Dequeue 10. Just for a while, imagine that this is an operation that I'm trying to do. Then this particular place would be removed. It would be empty now. Fine. This is now, let me change the color. This is empty now. Fine. This is empty. And now front would change and front would start pointing out here. So now front comes here. Fine. Clear? Front starts pointing here. Now in this case, you have seen that how Enqueue and Dequeue work. When we'll do the code implementation of it, we'll dive in deeper. But according to this, what do you think? What is the principle of queue? For example, in stack, the principle of stack was FIFO, right? First in, last out. Fine. Also, last in, first out was operating there. But what do you think? What exact principle operates here? 10 was the first thing to be entered, and when I dequeued, it was the first thing that was removed. So, don't you think it is something first in, first out? It exactly operates on the principle of FIFO, which is first in, first out. This is first in, first out. Fine. Whatever enters the queue first leaves the queue first. Whenever you enqueue a particular value or a particular element, remember the order in which it was put in the queue. It will leave the queue in the same order. For example, 11 was enqueued into the queue, or it would put into the queue after 10. So after 10 only this particular element can be dequeued. Fine. It cannot happen that 10 exists here and you dequeue 11. It cannot happen. On principle it cannot happen. Baki code se to kuch bhi jadoo kar do, isn't it? But on principle it cannot happen. Fine. So for queues, remember that queues operate on FIFO, first in, first out. Now what are the applications of queue? ये data structure कहाँ इस्तेमाल होता है? A lot of places where we want to build a pipeline of processes. Fine, there first process should be executed, this process comes and then it should be executed. Wherever you want to build that pipeline, wherever you want to build a chronological structure, there queues are very, very helpful. Fine. So you must understand that these are one of the rare data structures that solve the problem of chronology for you. Usually when you know that this is the chronological order of processes that they'll be coming, for example 1, 2, 3, 4, it is a subsequent order of processes that is going to come and they should be executed in the same order only, then queue is a super helpful data structure. Fine. Now in the next video we learn how these operations are implemented, how we implement queue. Fine. In the code format we'll understand that. Before that, whatever you think that there is something that you feel or you believe that was important in queue and you wanted to learn, or you liked something, or you had a doubt in it, go ahead in the comment section, tell me. I'll personally solve your doubts in the comment section. I'll guide the team as well. Fine, because top 3 comments can stand a chance to win the Prep Insta Prime subscription for free, so do not miss out on that. And go ahead, follow these social media handles so that you never miss any hiring update. Now, whatever good you learned, whatever knowledge you got in this video, go ahead, spread it. Keep doing good for others without any expectation. Good will come back to you. That's all. Have a wonderful day.